Dioxin is not your typical kind of toxic chemical which might affect one kind of effect, might only cause neurotoxicity or reproductive toxicity or cancer. Dioxin seems to have the ability to interfere with basic processes in our bodies, so that in fact dioxin has been shown in our experimental animal studies, and now we're seeing more of this in our human studies. Dioxin has been shown not only to cause cancer, but to cause effects on the skin, to cause effects on the gastrointestinal system, to cause effects on the reproductive system, on the immune system, on the cardiovascular system, on the endocrine system, and on the nervous system as well. Much of our concern for dioxin is based upon the fact, since it can affect basic biological processes, how cells divide and how they differentiate from one kind of cell into another kind of cell, we have a great deal of concern about exposure to dioxin during development, especially in the womb. And our animal studies have shown that dioxin, prenatal exposure to dioxin, is associated with effects on the developing reproductive system, on the developing nervous system, on the developing immune system. Some of the kinds of things that we see in children whose mothers were at the high end of the normal population, so we see children who their immune system appears to be suppressed so that they're more susceptible to certain kinds of infections. We see children who, when they go through puberty, the little boys appear to don't develop as well as you would expect them to develop, and we see changes in the behavior of both boys and girls. We see some effects on their learning ability, so that we see that some of these children, if you look at the population of children, you can see that the distribution of IQs is a little bit lower than we would normally expect from the population. We find persistent effects on these children, on their nervous system, on their reproductive system, on their immune system. Not everything here is signed, sealed, and delivered, but we do have some studies that suggest that there might be an association between dioxin and diabetes, between dioxin and endometriosis, and obviously between dioxin and cancer. When we study a chemical that seems to cause one kind of effect in one sex of one species, of one class of animals, I don't have a lot of confidence that that's something that may be applicable to people. But dioxins are chemicals that have been shown to affect every class of vertebrates, fish, amphibians, reptiles, birds, mammals. They've been shown to affect both males and females. They've been shown to affect many, many different kinds of tissues and organs. They've been shown to have effects during development, during childhood, during adulthood, in our animals. It's hard for me to think that people are going to be that different. Now, there is one endpoint that's now being shown to be associated with exposure of the men who become fathers, and that's based upon studies of poisoning episodes. And what we find in those cases was we are finding that there appear to be fewer little boys and more little girls born to men who were highly exposed, again, when they were children or young adults. The data does suggest, especially from the studies of the background populations, when you look at the children of women who for some reason have higher exposure in the background population, those children, their distribution of IQs, their sensitivity to, for example, infections, those responses or those children are potentially greater risk. Workers can be exposed additional ways than in the food that they eat. They can be exposed if dioxin is in the dust or is in the air of their workplace. They may inhale some of it, either as a vapor, in other words in the gas phase, or they may actually inhale it, and if it's bound to particles, what happens is it actually ends up being swallowed. Workers may also have some additional exposure through their mouth if they touch dirty fingers to their mouth. And there's a potential from exposure through their skin. Most of the occupational studies have focused, they've been mortality studies. They've asked, what have people died from? And is there an association there with the exposure to dioxin? We really need to be looking at incidence studies as well. For example, in most cases, type 2 diabetes may not be what's listed as the cause of death, and yet may very well be associated with elevated levels of dioxin, as an example. We know that dioxin causes cancer in animals. Dioxin has been tested in at least 19 now, different animal studies involving rats, mice, hamsters, and even fish, and been shown to cause tumors in these animals. We now have a number of human studies also, studies of populations who had high exposure to dioxin. And these studies lead us to conclude that dioxin does have the ability to cause cancer in people. Now, if we ask, well, how much dioxin do you need to cause cancer in people, we find that the amount of dioxin needed in the body of people is very similar to the amount of dioxin that was needed in the bodies of our experimental animals. And if we estimate what the risk is from dioxin exposure, we base that risk today very much on the human data, and the human data gives us similar numbers to what we've gotten from our animal studies. The International Agency for Research on Cancer evaluated this question very rigorously in 1997, and the conclusion of those panels, and I was a member of those panels at that time, was that the data was that dioxin is a known human carcinogen. Animal testing is a standard and an appropriate practice to understand the potential for human health effects. Essentially, all drugs and all surgical procedures are developed first in animals before they're applied to humans. It would not be ethical for us to take a chemical for which we have great concerns about the potential for health effects and knowingly expose anybody to this chemical. Nature is inherently conservative. The same processes that happen in rats and mice and monkeys and fish even happen in our bodies as well. Our understanding about the levels in our bodies that might be associated with effects is based on large part on our animal studies, which have shown that levels in the 10s to 100 parts per trillion fat adjusted, we always adjust our dioxin levels to fat, are associated with a number of adverse health effects, such as effects on the developing reproductive system, immune system, nervous system, also the potential for endometriosis, a number of other effects. Some people may suggest that some effects have a threshold below which nothing's happening. I would argue that in many cases, things may be happening below a certain level, we just don't have the ability to measure them. And in fact, for many effects that are caused by dioxin, we can't find a dose below which nothing is happening. When we look at levels in our experimental animals where we've seen effects, we see biochemical effects occurring at levels between 1 and 5 nanograms per kilogram. In other words, levels that are present in essentially most of our population. And we see, frankly, adverse effects on the developing nervous system, reproductive system, immune system, at levels from about 20 nanograms per kilogram up to about 60 or 80 nanograms per kilogram. Everyone in the population today has these chemicals in their bodies. Talking about a chemical that has effects at very low concentrations in the body.